In this video, I want to think carefully about one idea, arc lengths. By the end, I hope this idea feels simpler and more connected. So, what is arc length? I mean, how can we find an arc length of a curve? It sounds kind of complicated, right? However, it is actually very simple, and also I kind of assume that you guys have already learned how to find it in Calc 1 or Calc 2 class. In a nutshell, it's just you just need to find the distance, small distance between 2 points, and then you need to add up all the small distances using integral. Then you can find the entire distance of a curve. What interesting is, it's the same. It's still the same in multivariable calculus. So I hope I can explain this really quick. All right. Let me draw a curve. Okay, there's a curve, right? This is the start. This is the end. T equals A, T equals B. T is a variable of time. We are going this direction from A to B. And let me draw 2 points. Let's say here and here. R of T, R of T plus delta T, right? And then I'm going to draw a straight line between them, like this. So this is the segment line from R of T to R of T plus delta T. I want to call this curve L, and we want to find the full length of it. Just letting you know, R of T is a position vector. Position, right? How can you find it? As you can see, I have drawn the segment line between 2 points. Now, we just need to reduce the distance between these 2 points using limits. Then we can find the actual really small distance between these points. Now, I want to remind you that one of the most formula, the distance, let me draw here. Distance is equal to speed times time, right? We are going to use the same formula. For now, we are interested in finding the distance between 2 points. I want to call it delta L. So delta L is equal to, it should be equal to some kind of rate times time t, right? Since it's a position vector, that means we can find the velocity using derivatives. So this means R prime of t is velocity. All right, we are almost there. Since velocity has 2 things, speed and direction, we are only interested in the speed. So we need to find the magnitude of the velocity vector. So we are going to use magnitude of the velocity vector times delta t. And using limit, we can rewrite it as PL is equal to the same magnitude of the velocity vector times dt. All right, we just found the small distance between 2 points. Now we just need to add up all the these kind of small distances of the entire curve L. How can we do it? This is when integral comes in. We just need to use integral to find the total length. Let me show you. So we now know how to find the small distance from between 2 points, right? dl equals magnitude times dt. So the full length is derivatives from t is equal to a to b, the same formula, times dt. That's it, we're done. Now we can find the length of any curve. We can find any arc lengths using this integral formula. Super interesting, right? All right, we just talked about how to find an arc length of any curve, right? It's just a summation of infinitely many tiny distances of a curve. Now, lastly, I really want to talk about one more thing. It's just a very simple thing. For a space curve, which means in 3 dimensions, in R3, R of t, the position vector with the time t variable should be equal to x of t, y of t, and z of t, right? This is where VVF, vector valued functions, come in. This means r prime of t should be equal to x prime, y prime, z prime, right? So we can expand this formula into, let me use a pink colored pen. This is equal to integral, a to b. Remember, when you find the magnitude of any vector, you need to use square root of each component. So this is equal to x prime of t squared plus y prime of t squared plus z prime of t squared times dt. Alright, this is the expanded version of the arc length formula in multivariable calculus. That's it for today's video. I hope you guys are feeling this better than before. Finding an arc length of any curve is always just simple, so don't be panicked. In the next video, we're going to start talking about the fundamental idea in calculus, which is limits. I'm so excited to talk about how limit works in 3 dimensions. So please be excited as well. And until then, let's keep things simply connected. Thank you.